Welcome. Today we'll learn how to numerically integrate the function e to the power of 1 over x using the trapezoidal rule with n equals 4 subdivisions. First, let's set up our problem. We'll integrate from x equals 1 to x equals 2, dividing this interval into 4 equal parts. Here's what our function looks like over this interval. The trapezoidal rule works by dividing the interval into equal subintervals. With n equals 4, we'll have 5x values x0 equals 1, x1 equals 1.25, x2 equals 1.5, x3 equals 1.75, and x4 equals 2. Now, let's calculate the y values at each x point. These are y0 equals e to the power of 1, y1 equals e to the power of 0.8, y2 equals e to the power of 2/3, y3 equals e to the power of 4/7, and y4 equals e to the power of 1/2. The trapezoidal rule formula is delta x times the sum of 1/2 times y0 plus y4 plus y1 plus y2 plus y3. Here, delta x equals 0.25. Let's plug in our values. 0.25 times the quantity 1/2 times the sum of 2.718 and 1.649 plus 2.226 plus 1.947 plus 1.777. This gives us approximately 1.947 as our final result. Visually, we've approximated the area under the curve using these trapezoids. The more subdivisions we use, the more accurate our approximation becomes. In conclusion, we've used the trapezoidal rule to numerically approximate the integral of e to the power of 1 over x from 1 to 2. This method gives us a reasonable approximation without having to find an antiderivative, which would be very difficult or impossible for this function.